Hello everyone and welcome to another episode of the Trade Sailor Project. Today we're going to talk about resistance and power. So today we're going to get started with resistance and power. Let's go and have a look. So resistance and power. So the resistance is how much resistance the boat finds in the water at certain given speeds. We calculate that based on experience numbers. And then the power, so how we're going to push the boat to get to these speeds. Also, we're going to do a sailing prediction. It's based on a velocity prediction program. Also experience numbers and calculations. And we're going to see how fast the boat can sail with the sail plan we've got. All right, let's go and have a look. So how does it work? So first we feed in the calculation the data of the hull. That will give us for certain speeds resistance. This resistance we can turn into power required power by the efficiencies of the shaft line. So all the losses we have on the shaft line we take into consideration, and that will give us for the given speed our required power. So these are the data I got to for auxiliary powering. So we want to push the boat without the wind. In this case, we've got based it on two electric inboards, 160 kilowatts, 2 times. They weigh approximately 400 kilograms each. A little bit more about it later. It will be a 700 volt system. Have an average outload of 1 kilogram, and the batteries we've got as well calculated. So we can see that the speed runs up very quickly, exponentially actually in the higher speeds. The maximum speed I calculated for this setup will be 10.25 knots. That's about 10 knots. But you also can see if you go a little bit less, like 9 knots or 8 knots, that the power almost for 9 knots almost halves. So exactly halves. And the slower you go, the less power you need. And you can see the same in the range. The range is very, very high if you go very, very slow. And the faster you go, basically, the less far you can get on the battery pack. So I've got the following speeds and the following ranges. So we've got 110 nautical miles at 5 knots, 37 nautical miles at 8 knots, 24 nautical miles at 9 knots, and 30 nautical miles at 10.25 knots, or full power. These are not very, very big ranges, but we are a sailing boat, and this is what we get. So I've been trying to find some possible drivetrains, some electric motors to power this project. Of course, my first go-to was Oceanvolt. They are very, very much the leader in the electric propulsion and in the yachting sector, the small yachts. I had a good contact with them, and they very clearly indicated that they don't do anything high voltage. Seeing that we got a lot of power, we need a high voltage to keep the amps down. And they said, no, they can't do it at this time. Maybe in the future. The reason I liked Oceanvolt is that their regeneration. They've got a servoprop system, so prop which you can adjust the blades electrically, and therefore optimize the regeneration and also the propulsion, of course. But the regeneration is especially they're very, very good at. So it's a shame, no Oceanvolt. Which I found Stock Electric in the Netherlands. They're a company, they're upcoming. They're very, very busy to get into this part of the market. Had a very, very friendly contact with them. They're very helpful. They expect to have their motor on the market in 2025, which would be for this project still a good option. So this is the motor I will be using from now for further in the design. I've got some preliminary data from them. They don't have a fine definite data yet. They're busy with a German manufacturer for manufacturing the motors. But yeah, they are very helpful and very, very good contact with them. Also, I found Bosch Power. I've sent them a question for information, but I haven't received anything yet till today. So, but I'll keep you updated. So the sailing speeds. How fast will she sail? This is based on the VPP program, the velocity prediction program, and it gives a polar diagram. So it's a circular, in this case a half circular diagram, which shows the wind direction, the true wind direction, and the predicted speeds. So for a given wind speed, we get a boat speed. So in this case, we're looking at about 12 knots, 10, 11 knots, full speed, about 20 knots of wind from the beam. Because the wind comes from the back, We have about 9 knots, and close hold, of course. The closer you get to the wind, the slower the boat goes. It's preliminary data, so it's I don't have all the input information yet because we haven't done the stability test yet. So I've based the center of gravity on the waterline, and I haven't defined the downwind sails yet. So we could put a spinnaker on it if you're going downwind, which will increase the downwind speed. But this is it's roughly similar to the hull speed, which makes sense. So we got enough sail. So that was it for resistance and powering for this week. Hope you enjoyed it. If you got any questions, feel free to put them in the comments. I hope to next week. If you got any questions of any ideas and inputs for the weights and moments, let me know in the comments as well. And hope to see you next week. Thanks for watching. Bye.